Alright, in this video we're going to look at how we solve absolute value inequalities. This is very similar to how we solved absolute value equations with just some slight differences. If you remember, when we solved absolute value equations, we split them into two linear equations. When we solve absolute value inequalities, we're going to split them into two linear inequalities. Now when we do this, there are two important things that we need to remember. First of all, the second inequality, which is going to be the one that has the negative number on the right, should have its inequality sign flipped. So if it was absolute value of something is greater than 2, we'll split that into the two inequalities. That thing is greater than 2, and that thing is less than negative 2. The other thing that we need to know is that some absolute value inequalities will become AND compound inequalities, and some will become OR compound inequalities. And we can very simply break these down into two groups. When we have the absolute value of something is less than a number, that's going to become an AND inequality. And that also holds true for when we have the absolute value of something is less than or equal to a number. And when we have absolute value of something is bigger than a number, that's going to become an OR inequality. And that also holds true for when we have the absolute value of something is greater than or equal to some number. Now, why is this the case? Well, without even thinking about solving this, suppose I have an inequality like absolute value of x is less than 2. And let's make it less than or equal to 2. Now think about the numbers that make this inequality true. Basically, we need to take the absolute value of a number and have it be less than or equal to 2. And that includes numbers like negative 2, negative 1.5, negative 1, 0, 0.5. I'm just listing off a bunch of numbers that make that true. But all of those numbers fall in between two values, negative 2 and positive 2. And when we have numbers that fall in between two values in a compound inequality, we're looking at an AND inequality. And so that's what we're looking at in this case. And I could do the same thing if I considered an inequality like absolute value of x is greater than 3, and listed off some of the numbers. We'd have like 4, 5, 5.2. But we'd also have numbers like negative 3.5, negative 4, etc., etc. So we have two different disjoint groups of numbers here, and that means that we're going to have a gap in the middle, and so this turns into an OR inequality when we split it. All right, let's look at some examples of solving absolute value inequalities. All right, absolute value of 2x minus 5 is less than 7. This is going to be an AND inequality because of the direction of the inequality sign. And so first thing I'm going to do is get rid of the absolute value signs in the first inequality. And then when I write the second inequality, the one with the negative number, I'm going to flip the inequality sign. Now I have these two inequalities to solve. And we'll go ahead and solve those. Add 5 to both sides, divide both sides by 2, add 5 to both sides, divide both sides by 2, and there's our solution to that absolute value inequality. Do the same thing in part B, only now, because of the direction of the sign, since its absolute value is greater than a number, this is going to turn into an OR inequality. And so we've got 3x plus 6 is greater than or equal to 15, or 3x plus 6 is less than or equal to negative 15. And then we'll solve both of those. We'll subtract 6 from both sides, divide both sides by 3, subtract 6 from both sides, divide both sides by 3, And another thing you'll notice with the whole and or concept is that these two inequalities in part A are facing towards each other. You know, we have x is less than 6, looks like this. We have x is greater than -1, looks like this. And so the overlap of the two is where the solutions lie. In the or inequality over here, we have x is greater than or equal to 3, and we have x is less than or equal to -7. And so we have the two different branches heading in different directions in that absolute value inequality. All right. Solve and graph the absolute value inequalities here on this page. So first we'll set them up. First one is an or inequality. We flip the inequality and change the sign in the second one. And then we solve these. Subtract 3 from both sides, divide both sides by 2. Subtract 3 from both sides, divide both sides by 2. So x is greater than 1, or x is less than -4. And there's our graph. All right, part B. This one's going to be an and. So we've got 3x minus 4 is less than or equal to 8. And 3x minus 4 is greater than or equal to -8. All right, and we solve. We add 4 to both sides. Divide both sides by 3. We add 4 to both sides. Divide both sides by 3. And so we want, let's see, we want x is less than or equal to 4, and x is greater than or equal to -4/3. That's going to be in between -1 and -2. And so we want where these two overlap. So we've got a point at -4/3 and a point at 4, and a shading in between. Now something that I do whenever I put a integer value on a number line is a number where exactly that value is supposed to be. It's supposed to be at -4/3. This makes it a little more helpful and more clear to read. All right. Oh, a couple more. Now, if you remember when we were solving absolute value equations, we had to get the absolute value signs by themselves before we split it into two linear equations. We're going to do the same with inequalities. Here we've got some absolute values involved in inequalities, but the absolute values aren't by themselves, and so we need to get them by themselves first before we split them into the two inequalities. So I'm going to add 7 to both sides and divide both sides by 2. And then I'm going to split this into two inequalities. That's an or. Oops. All right, and now I'm going to solve these. Add 1 to both sides. Add 1 to both sides. And so let's see, greater than or equal to 7/3. 7/3 is between 2 and 3. And less than or equal to -5/3, that's between -1 and -2. We've got -5/3 there, and we've got 7/3 there. And shade to the outside. By the way, if you have trouble recognizing where these numbers fall on a number line, just go ahead and break your calculator out, do that division, and see which two whole numbers that fraction lies in between. All right, and the last one here, again, we're going to isolate the absolute value before we split it. So we're going to add 9 to both sides. Divide both sides by 3. This is going to be an and inequality. We've got x minus 5 is less than 4, and x minus 5 is greater than negative 4. And to solve, I just add 5 to both sides, and I add 5 to both sides. So we want x is less than 9, and x is greater than 1. And so we're looking at the overlap of those two regions, and our graph should look like that. All right, and that's how we solve absolute value inequalities. Hopefully you picked up a few tips and pointers. Specifically, make sure that you're watching for the direction of these inequality signs to see if it's an and or an or when we split it into the two. Also, that we make sure that when we write our second inequality, the one with the negative, we flip the inequality from the original absolute value equation. And also that we get the absolute value signs by themselves before we try and split them into two linear inequalities. All right, that's it on solving absolute value inequalities. See you next time.